Welcome back to the HFworks video series. A technique to improve the frequency response of a microstrip low-pass filter. The defected ground structure is a new technique to improve the frequency response of low-pass filters. This technique consists of etching out slots or defects on the ground plane of a printed microstrip board. It is a simplified form of electromagnetic band gap structure. To study this important topic, we choose the popular EMworks high-frequency simulator, HFworks. We will use a microstrip low-pass filter, with and without a defected ground structure, as an example to illustrate this technique. Since HFworks is an add-in to SolidWorks, the #1 3D CAD software, the creation and modification of the geometry is as easy as a pie. Therefore, we skip the geometry creation part and dive straight into HFworks. Since the Sparameters is the standard metric to study the frequency response of filters, we use the Sparameters module of HFworks. To add a new Sparameters study, right-click on the project name and choose Sparameters. Give it the name of DGS. Click on the Frequency Sweep tab. Enter 1 GHz for the start frequency and 20 GHz for the end frequency. Enter 51 for the number of frequency points. No need to check the other tabs. The default is adequate for this application. Click OK. A new Sparameters study is added to the HFworks Manager tree. Let's apply the material for each body. Right-click on Air box to apply air. Right-click on Filter Substrate to apply FR4PCl FR204 material. Let's apply the necessary boundary conditions. Right-click on Boundary Conditions and choose Port. Apply port 1 as shown. It is a microstrip wave port. Click OK. Apply port 2 as shown. It is again a microstrip wave port. Click on Boundary Conditions to add perfect electric conductor boundary. Choose the bottom face of the substrate which presents the ground plane except the H-shaped slots and the printed metallic surfaces on the top of the substrate, as shown. Click OK. To create another study without the defected ground, just copy the above study. Give it the name NoDGS. All input parameters given to the DGS study remain the same, except the H-shaped slots. Edit the perfect electric conductor boundary. Add the H-shaped slot faces to the list of existing faces. It is equivalent to eliminating the defected ground because the ground plane is all metallic now and has no slots. It becomes a regular microstrip low-pass filter without defected ground. All the pre-processing is now complete, and we are ready to run the studies. Right-click on a study name and choose Run. Solving will take time. Let's instead examine existing studies that were run previously. After the run is complete, Results folder is created and contains different type of results. Circuit Parameters folder contains the results table and 2D plots. Electric field and magnetic field folders contain the near electric and magnetic fields in the entire model. Port fields folder contains the electric and magnetic fields on the ports. Loss density and total loss folders contain the volume and surface losses inside the structure. We shall concentrate on the S parameter results. Right-click on the Plots folder and add a new 2D plot. Choose All from Source. Choose S21 from Parameters and click Add. Click OK. The plots of S21 versus frequency appear for the DGS and no DGS studies. Clearly, the microstrip low-pass filter without the defected ground structure has a stop band bandwidth from 2.54 GHz to 9.57 GHz at 20 dB suppression level and cutoff frequency of around 2.03 GHz. On the other hand, the filter with the defected ground structure has a much wider stop band. That is, a stop band bandwidth from 2.05 GHz to 16.5 GHz at 15 dB suppression level, as well as a 3 dB cutoff frequency of around 1.98 GHz. An impressive improvement in the frequency response of this low-pass filter. Double-click on the results table. It contains all circuit parameters for all frequencies. Click Close. From the electric field folder, we can create different types of plots: fringe, vector, or streamline. To show the fringe plot of the electric field, just click on the electric field icon. The magnitude of the electric field is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. To show the vector plot of the electric field, just click on the second icon with the vector symbols, as shown. To show the volume loss density, just click on its icon. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and Generate. Customize your report and choose either HTML or Words format. Click OK. To conclude, the introduction of the H-shaped defected ground slots has greatly improved the frequency response of a low-pass microstrip filter. A tool like HFworks is indispensable to design RF and microwave filters and study their frequency response. You cannot guess it. You must simulate it. Thank you for watching.